Okay, so in the last video we implemented some functions, member variables, and also some vectors. Now it's time for us to define these vectors and the values they hold. So we need to write a couple of functions, and we'll be writing them in the public space. Okay, so first thing we need to do is set the x. So the x will be a, well, basically everything in here is a vector for double, but we take it by reference, and we don't need to write the name of the vector here. We will write that in the CPP file. Let's actually declare all the functions, and then we will copy them there. So void set x, void set y. So void are functions where nothing is returned, but everything is done inside the void function. And we also need to set xc and yc. So xc set xc set yc, but to set xc and yc we will need two vectors because they are calculated from the x vector. So just copy this part and put there, delete this extra stuff. Okay, so now we have x, y, xc, yc, and now we have to do the interpolation factor. So let's just copy paste this and say set fx and fy, simple as that. But this time we will actually need 3 because we need a reference to the x vector, we need a reference to the cell center vector, and also we need the interpolation vector itself. So fx for x by reference, and put a comma and delete this extra stuff. Okay, let's just build to see if we get any errors. So I noticed that there is some errors from, not errors really, warnings saying that some stuff will be initialized after, for example, xc will be initialized after y. It's not really a huge problem. If you want to solve that kind of error, it's best to just check what you have declared first, and then in the initializer what's the ordering here, and the declaration order and the initialization order should match to remove these warnings. It's not going to affect the results, but yeah, it should be okay. Right, so now I'm just going to copy these and paste it under the after the destructor function. So just pasting it here, and let's go one by one. Now these functions are declared in this class called grid, therefore they are member functions of this class. Therefore you need to say that they belong to the grid and 2 colons, and then of course these functions will appear naturally. Now at the same time you need to put curly brackets to define the function and the name of the vector. It can be, because we are taking it by reference, it can be any name. So I'm just going to call this vector x. Okay, so let's actually do this for everything else as well. So first I'm going to put curly brackets everywhere. After that I'll put the grid class scope resolution operator. It's called scope resolution, and here, and let's put this guy. I'm just gonna copy it with the 2 colons, and right, and now the names here will be vec y. Here will be, to set the cell centers, we will need vec x, and let's call this guy vec xc, and here for y it will be vec y and vec yc, and if you maintain some consistency, should be better for you to understand. So for interpolation factors, we need vec x, vec xc, and also vec fx, which is the interpolation vector. Okay, and here we need vec y, vec yc, and vec fx. Okay, so let's see if we have any errors at the moment. So let's just build the project, and it's working fine, so no errors. Just need to actually implement these functions now, and the workspace pane has gone, so let me just click that and remove this. Alright, so let's, first things first, x and y. So if you are familiar with C++ and other let's say Fortran, MATLAB, or in all that, the I and J starts from 1 and goes on. In C and C++, well, that's all I know for now. Definitely I and J starts from 0. So that's something you have to keep in mind. Bear in mind that when you declare a vector or a list or a matrix or whatever it is, an array, it starts from the position 0. So don't it's just something that you should keep in mind. Okay, so because we have initialized everything to the value of 0.0, if we actually, let's go ahead to the main file, let's just say that we want to actually implement this class now, call this class. So let's call this class grid. I'm going to say integer n is nx, let's say nx equals 7, and ny equals 7, and double length x equal 1.0. Now I need to include this grid class, of course, so include grid.h and put this double comma, and now we can actually call this. So when I write grid, the class name should come up, and I'm going to call this my grid and give it nx, ny, and length x, and let's build. Now when this class is called, everything up to here will be done. So basically n, m, everything here, all these vectors will be initialized, sizes and the initial values, and also these ni, nj, nim, and njm will be calculated, and dx and dy will be calculated. Now that's an assumption we just made, and let's actually see if the dx and dy that we have calculated in the grid class is correct or not. So we can say cout grid spacing dx, and then we will say my grid dot dx and end the line. But when I click the build project, it will give me an error saying that the dx is private. So what we need to do is just go to the public part of this class and just say that we want to return, so just write something, ret dx I'm writing, and then just say return dx. Okay, so basically it will return a double if this function is called, and it will return the private member variable dx. So mygrid dot return dx. Let's build. So now it should be okay. Now let's actually run the project and see. So the dx is 0.142857 as I showed you in the earlier picture or the earlier lessons. Okay, so now we know that the grid spacing is okay and we can call this class. Let's move on to these functions that hasn't yet been called. Okay, so as I said, it starts from 0. So we know that at I equals 0, x will of course be 0. So there's no need to change that unless you want to start the grid from, let's say, 1.0 or 2.0 or another value. But we will be starting the grid x and y from the 0.0 position. Okay, so now we are going to write a for loop saying that from the second position, which is I equal 1, until the size of this vector and I plus plus vec x, which is the x vector at ith position, vec x at ith position will be equal to vec x at I minus 1 plus the dx value. Okay, so it's quite simple. Once that's done, if let me just go to picture and remind you that the way this grid is collocated and discretize the x positions at the last and the one before the last is the same. Therefore we need to tell the the code to basically say that vec x at the size or the full size last position minus 1 will be equal to the vec x at size minus 2 position before that. Okay, so now we've told this function how to calculate this x vector and also how to modify the last position. Let's actually call this function. Let's call mygrid dot what's this called? Let's see, set x. My bad, I want to call this actually in the constructor, so not through the main file. So set x and we call using x. Okay, so the constructor can call functions as well, because this function calls for vector x, which is here, and because this x vector is a member function of the class, we don't need to do much. Just call the function in the constructor using set x, which is the name of the function, and the vector we want to modify, the vector is x, and therefore this workspace keeps disappearing for some reason, but not a huge issue. So now the x will be discretized. Let's actually check So for int I equal to 0 to I is equal to my grid dot x dot size I plus plus c out my grid dot, it's actually my grid underscore my grid x at all the I positions, and give some spacings. That's it. Let's build and eliminate any errors. No errors, so let's run. Okay, so as I said, the first spacing is plus dx plus dx plus dx, and of course the last two have now been modified to have the same values. Now it's just a matter of copy paste to do that for y. So just copy this function, just a great copy and paste, just vec y, because it's uniform spacings and the length in x and y direction is same. We don't really need to change anything, but for safety let's just write here dy in case we want to change the length in y direction or the number of nodes in y direction. Right, so x and y has now been set. Build slowly, step by step, so that we don't make much errors. Now it's time for us to do the cell centers, compute the cell centers. Alright, so I'm just going to copy this here and say that for I is equal to x dot size, and we want to modify the vec xc, which is the cell center vector. So xc at I from the second position, but in here we write 1 because we ignore 0th position, because xc at 0 is on the boundary, so it will be 0.0 of course, and basically xc will be equal to vec x at I plus vec x at I minus 1 and multiplied by a value of 0.5. So basically the midpoint value between two x spacings. But for the last position we need to say that vec xc at vec x dot size minus 1 will be equal to the x vector value there, minus 2. Okay, so just for saving time, let's just copy it here, and then we will print this xc and yc and see what's going on. So let's just put here y, and yc. We want to modify yc, and here also y, and I think that's all of it. Let's just build to see if okay, so it's okay. Now let's just call these functions in the constructor. Set y, set xc, which will call for x vector and xc vector, and set yc, which will call for y and yc vector. Now all these functions will be called from the constructor, and we want to print the xc values. Okay, build and run. So because of the modifications we did, now let's actually print x vector as well, so that we understand better what's going on. So x and xc, there's no need to print yc because it will be exactly same. So x and Still not clear because there's no spacing between them. So let's just print out an empty line. Then we will see. Alright, so at the top we have the, not sure if it is clear, and I don't know. Oh, we can zoom in. Okay, right. So now we have got the X at the top. So from here to here to here to here to until the last two, which are the same. And then we've got the XC, which is for the first node it's same, and after that it's the midpoint values between two X positions, and at the last position it's the value between 0.857 and 1. Okay, right? So now we know how to get the XC and the YC correctly, and we've got only two more functions to write for this particular lesson, and that should be fairly easier than everything else we have done. And for the purpose of ease, I'm just going to copy this guy to the fx and also copy this guy here. Then we will modify. So now we are setting the interpolation factors, and the fx, which is the interpolation factor, will be equal to the let's actually go back to this picture and discuss. So basically it's this spacing between the cell center and the cell face divided by the cell center distance to the nearest cell center in the east direction for X and in the north direction for Y. Right, easy peasy there, and let's do that. So basically it will be vec X, which is the X position at ith node, and this time we actually do this for all the entire length of vector. So we start from 0th position. So vec at I, so xi minus the cell center, which will give us the small distance from cell center to cell face, and this will also be I. Then we divide that by cell center, so vec xc at I plus 1 minus vec xc at I. Okay, and okay, just let's copy this here and change fy is equal to vector y, so this will be y as well, divided by, sorry, minus yc and vec yc, vec yc. I have some doubts about this, but let's actually call these functions. Set fx, which will call for x, xc, and fx, and set fy for y, yc, and fy. Let's print this fx first. Let's delete this x vector, and let's build the project first. There is a right here I need to change to fy because this is interpolation in y direction. So let's build again. Okay, and let's build and run. Okay, so the interpolation factors are here. So for the first control volume, let's actually go back and open that picture that we used to discuss this. Okay, so for the first one it is 0, For everything else, like we said, because it's uniform spacing, it's half until this control volume. Here the distances are doubled, so the interpolation factor is 1, and of course on the boundaries it will be 0. So there's no need to interpolate there. So the boundary control volumes have 0, 0. Even though it's minus, it's not really a problem because there'll be no interpolation done there. So all the internal volumes have zero 0.5, and the last internal volume has a interpolation factor of 1. Right, so the interpolations have been done as well, and now let's see fx and fy. Okay, so that's probably the end of this lesson. And in, I know it took some time to do this, the grid class, but it's kind of, if you understand the grid and the interpolation and the cell centers, then everything else in this course will be particularly easy. Let's hope. And in the next lesson, hopefully, I think we're going to implement the fields, and after that the finite matrices, and so on. Alright, so if you have some doubts, don't hesitate to ask a question or message me. If I can, I will try to reply. Thank you.